So far in algebra, we've talked about linear functions. So linear functions have a constant increase or a constant decrease situation. They are straight lines. But an exponential function does not have a constant increase or decrease. Instead, it's increasing or decreasing by a percent. So if you have the equation y equals ab to the x, this is the general form of an exponential function. So the y-intercept is the a value. And the growth factor we call b, the growth factor, is the b value. So it's not really a slope, it's just how much, what percent is the function increasing or decreasing by. So when b is greater than 1, the function represents exponential growth. And when b is less than 1, the function represents exponential decay. And actually, I'd rather be more specific. Instead of putting b as less than 1, I want to write when b is between 0 and 1. So if b is 0, remember anything, 0 to the anything power is just going to be 0, so it's just going to be a flat line. So exponential functions look like growth. This looks like growth or decay. See, this one's going down, up from left to right, so that's growth, and this is going down from left to right, so that's decay. So example, graph the following exponential equation by making a table. So what I'm going to do is I'm going to fill in this table using this function right here. So I'm substituting x is negative 2, x is negative 1 into the function. So it's going to be 3 times 2, 2 to the negative 2, 3 times 2 to the negative 1, 3 times 2 to the 0, 3 times 2 to the 1, and then 3 times 2 squared. So order of operations, you need to do the exponent part first. So 2 to the negative 2 is actually 3, this is going to be 3 times 2 to the negative 2 is 1 over 2 squared, which is 1/4. So this part is 1/4. So 3 times 1/4 is 3/4. This is going to be 3 times 2 to the negative 1 is 1 over 2 to the 1. Because it's the negative exponent, you need to move it. So this is 1 times 1/2, so it's going to be 3/2. So if it were to be a linear function, then the rate of change would be constant. So the distance between here and here would be the same as the distance between here and here. But it's not going to be, because if I do 3 times 2 to the 0, 2 to the 0 is 1, so this is going to be 3. So you can see that the distance between here and here and here and here are not the same. And the next one's going to be 3 times 2, which is 6. And then 2 squared is 4. 3 times 4 is 12. So you have, instead of having a common difference or common number that you're going up or down by, you have what's called a common ratio right here. So I'm actually multiplying by 2. So 3/4 times 2 is 3/2. 3/2 times 2 is 3. 3 times 2 is 6. 6 times 2 is 12. That 2 is our growth factor. So we know that this is going to be an exponential growth. We also know that the y-intercept is 3, which is on my table right here at 0, which is where x is 0, it's going to be the y-intercept. The y value is 3. So I'm going to go over here and graph it. You have to be careful on your scale because you have to fit 12. So I'm going to go up by 2s. So I have 0. Okay, so then I'm going to go 2, 4, 6, 2, 4, 6, 8, 10, 12. And then on the x scale, I'm just going to go over by 1. So negative 2 3/4 is right there. Negative 1 3/2 is right there. It's kind of hard to do it with a finger. And then 0 3 right here. 1 6. And then 2 12. So my function has what we call an asymptote. And you're going to do that more in algebra too. But an asymptote is when you get very close to a value, but you do not cross it. So when I make my graph, it looks like this. So I'm getting very close to this axis right here, but I'm never going to cross it. So I don't want you to cross it because there's never a value for x that's going to give me a y value that's negative. So this line right here is called an asymptote, this line. So if you see that word, it means that the function is getting very close to that line, but it's not crossing that line. So an asymptote is a line that a function gets close to but does not cross. So that's a general form of how you graph an exponential function. So down here, evaluate. So evaluate means to plug in. So you're going to plug in x is negative 1. So it's going to be y equals 10 times 3/2 to the negative 1. So if we have a negative exponent, what we're doing is we are actually flipping these two around. So it's going to be 10 times 2/3 to the 1 power. So this is going to be 10 times 2, which is 20 over 3. Okay, letter B is 3 times 5 squared. Do order of operations first. So do 5 squared. So this is 3 times 25, which is 75. And then letter C, 2 times 1/3 to the negative 3. So if you have a negative exponent, it's going to be 2 times 3 over 1 to the 3rd. So this is going to be 3 to the 3rd, which is 27. So 2 times 27 is 54. Okay, and then given the domain, so given the x values, find the y values, show your work. So this just means given these x values, plug them in to get the y values. So if I plug in negative 3, what do I get? Well, it's 1/2 times 2 to the negative 3. So that's 1/2 times 1 over 2 to the 3rd. Because I need to make this go to the bottom. So 1/2 times 1/8 is 1/16. Now if I plug in negative 2. Oops, plug in 2. Negative 2 for the exponent. So it's 1/2 times 1 over 2 squared. So that's 1/8. Now if I plug in negative 1, this is 1/2 times 1/2, which is 1/4. So if this keeps going down by 1, I can see what the pattern, or if this goes going up by 1, I can see what the pattern is. So my range is going to be, I'm going to put this in brackets because it's a set. So it's 1/16, 1/8, 1/4. And now if I plug in 0, it's going to be 1/2. And if I plug in 1, it's going to be 1. And you can check too if you didn't see the pattern and do it yourself. Okay, suppose you invest $2,000 and it doubles in value every 8 years. How much will the investment be worth in 24 years? Because it's doubling, this is an exponential situation. So if it's doubling, tripling, halving, it's going to be exponential. So I'm going to write the general function for an exponential. So it's y equals ab to the x. A stands for your initial value. So I'm going to write y equals, my initial value is $2,000. Now b is my growth factor, so double, so it's going to be 2. And then x is going to represent the number of times it doubles. So if it doubles every 8 years and 24 years have went by, it's going to double 3 times. If it's doubling every year, and it's 24 years, then it's going to be 24 right here. So now I do 2 cubed, which is 8 times 2,000. And I get 16,000. So the answer is $16,000. You want to answer in money.